please. And I guess to start, we did receive a couple of questions via email before. So my plan is to kind of start there. And then as questions kind of start to build in all of your minds, you can put them into the chat and I will read them in the order that they come in. Lee and Andrew will also be moderating the chat, monitoring the chat for us when they are not speaking. So we'll definitely have you covered. And if there's anything we can't get to, we will put a blog post together and get that scheduled for the next couple of weeks. We'll definitely be sure to email that out to you as well. If you do have any questions specifically about a career in data science, time permitting, we may not go over those today because we have scheduled a separate event for that in late August, I believe. So if you are better suited to attend that event and you would rather do that than this today, or you want to attend both, I'm also going to ask my colleague Gina to just drop that registration link in the chat right now as well, so you can kind of do what you'd like. Okay. So without taking up too much more of your time, I wanted to start by just starting out with the basics. So Lee, I'm going to put you on the spot first. And the first question we had was, what does data science mean to you? So if you don't mind kicking us off, I would appreciate it.
Sure. So this is kind of a personal question as well, right? You know, it's a very much an emergent field. You know, it's relatively new, and you know, people still have different viewpoints on the field, what it is, what it could be, what it should be. So for me, kind of the way that I would coach this is, you know, from the technical side, like it's really the confluence of multiple fields that already existed. So, you know, confluence of statistics with computer science, with business, and with software development. So kind of it's those four things, kind of what's the edge of those four different areas, and that's kind of where you find data science. So as a result, most data scientists tend to be okay at all four of those things, but generally perhaps not as deep in any one of them as, let's say, a specialist software engineer would be in software engineering, or a specialist subject matter expert would be on the business side. And that's also a key thing as well, that data science is really, it's a business discipline. You know, computer science, stats, they already exist in academia as their own pieces. You know, data science is really coming, you know, how do we apply those things to business or organizational problems, but really problems in the real world rather than abstract, like mathematical problems.
Okay, awesome, thank you. Andrew, since it's opinion-based, if you could give us your version of it, that would be great.
Sure, I agree by and large with how Lee outlined things. You know, it's obviously the combination of those different factors, you know, computer science, like Lee said, statistics, business, all of that sort of thing. There's a lot of kind of goofy looking charts where, you know, they've got the different circles overlapping, like this is data engineers and this is you know, computer scientists or software engineers and this is business analysts, and then, you know, they all overlap in one tiny little area, and people say like, and that's the data scientist. But like Lee said, it's important to remember that since it is such a new field, the path to becoming a data scientist and what businesses think of what a data scientist does is very diverse. Even within that little bubble, you've got some people who are really focused on deploying models, and you've got people who are focused on designing the custom algorithms. You've got people who don't, you know, maybe really keyed in on the business side, but they you know, might not have quite as deep of a mathematical framework for these problems. And one of the interesting things about data science is that because it overlaps with so many different fields, there's not just one data scientist, it's almost an organizational approach of how does a team approach data science problems, because there's just not enough time in the day for one person to do everything.
That's a really good point. Okay, so I guess since we have nothing else in the chat, I'm going to keep going with what we got beforehand. So the next one is, what is MLOps? And I guess I should say that's short for machine learning operations. Dealer's choice on who wants to take that one.
Lee, I'll let you jump into this one, and then I'll provide additional thoughts as we go.
All right, so this is something that I really like, and this is like my thing. One, this is a super new field. So the term was coined in 2019, right? So, you know, as a field, this is 2.5 years old, not even 3 years old yet. So the kind of pithy answer to this is no, it's DevOps and machine learning. DevOps is a tried and true path. It's become the way that many software engineering projects go because it's great practices. It really helps to maintain quality, maintain speed of delivery. It's a great thing to do. With machine learning systems, or really anything that's really called like a data-intensive application, an application that requires both code and data to be built. And code only changes when either coder changes. Data changes all the time. Data is a living, breathing thing. When the world changes, the data it generates changes as well. So any system that includes that needs to be able to deal with those changes as they come. So this is kind of why DevOps itself then kind of it doesn't quite cover the full range to cover machine learning. So MLOps is the question of how do I extend DevOps, not replace it, not change it, right? It's still all those things still apply, but how do I extend? What bits do I need to add to a DevOps framework in order to make machine learning models go to production, sit in production, maintain themselves in production, stay fresh, stay giving out accurate, good quality results for our predictive analytics? These are kind of all the questions that we deal with within MLOps. And why it's really cool is because it's so new, there isn't yet a way of doing MLOps. So it's a really fertile space to kind of come and to have an impact and really be on the bleeding edge of things without necessarily having to be a deep PhD in some very, very niche field. So
absolutely, I agree with that. It's interesting because the traditional path to becoming a data scientist, and this is evolving over time, but it was you've got your PhD in at some good school, and it's either in statistics or physics or something like that. Moral of the story is that you're really good at crunching these numbers. You know how to code, and you know how to create interesting problems. And over time, the funnel of people who have been getting data science jobs sometimes is people who were developers who got an interest, because the bar is lower, like we were talking about before, because there's less custom machine learning algorithms that need to get written. A lot of the things you can just kind of use. And more and more people are able to get bachelors and whatnot in data science. And as a result, the field has got a lot of these either individuals who are good at conducting personal experiments or individuals who are maybe more on the business analyst or engineering side. But there's some quote out there where it's about 80% of models don't make it into production. And I'm sure that's an apocryphal quote of some sort, and I don't know where it came from, but in my experience, something like that is true. The question of, yeah, you've got this person, they're working on their personal machine, and they've got the scores, and then they kind of hand off the model to somebody. How do we actually make sure that that model is going to be successful? And it's almost like what's happening to data science is what was happening with the quote unquote big data boom. Hadoop came out and we started collecting all data everywhere, all of this information, and then it was like, okay, so what? And then we had all these analytics services that built on top of it, making this information actionable, et cetera, et cetera. The same thing is happening with data scientists. There's this huge influx of interest of building these models, but now we need to make sure that it is as easy as possible for that handoff between the people doing the experiments to the people making sure that the models are working and being maintained in production.
One more piece of that as well is, the kind of end goal of any data science project should be something that can be used by an end user, be that a business user in a dashboard, in Power BI, in Tableau, be that a application that needs to use some kind of data science system to make choices or to give better functionality. A piece of MLOps as well and going to production is exposing the model to those end users or that end application, without which the whole thing is just an expensive science project.
Okay. So I'm thinking this question came in from the same person, but how is MLOps different from my existing machine learning model in production?
Well, if you have a machine learning model in production, congratulations. That is no small small feat. And the way that that can manifest itself is somewhat how I described before. You've got a data scientist, they build a machine learning model, say that they have, built a model which detects in an image if the image contains a cat or a dog. And you're able to save that model, because a model is really just a complicated formula, if you will. It takes information and it produces an output, and they've been able to hand that off, and it's in some system where it's able to be utilized behind the scenes. Where with MLOps, there's a number of additional considerations beyond just putting it in production. There's the monitoring of the model. So how is your model performing over time? How do you update your model? So given the performance of the model, do we see performances decreasing, or the types of images that are coming in are different? People are sending more pictures of cats and dogs and poses that the model wasn't necessarily trained on. A lot of those sorts of questions. And then what is allowing us to retrain the model with the new information, evaluate that model, and put it in production in a seamless way, rather than that going back to your personal computer, running a couple of ad hoc experiments and just getting that other object and putting it out. How do we make sure that the whole process is traceable, traceable, reproducible, on a larger scale? That's when I would say, and using CI/CD practices, that's when I say it becomes a model that is using MLOps rather than just a model in production.
So I'll tell a little story here, right? So I've been doing this now for almost 10 years. It's 9 years. I started in 2013, and the first model I ever built was for a company called Renishaw in the UK, which is where I'm from originally, and we were detecting cancer samples. Cancer in various kinds of images that were taken from medical diagnostic equipment. So I built some models that were that did something useful, and I had to deploy them to production. Now I was a fresh out of my PhD. I'd never done production grade work before, and this is kind of before MLOps was, or long before MLOps was a thing. I built a model. It took me over 4 months to get that model into production. I had to build my own entire front end application. I had to then push the model into that somehow. And then whenever I wanted to change my model, let's say I created model V2, I had to go and rebuild the entire app from scratch every single time. So that was not fun. And it's still a common problem in business is the model's ready to go. It can take 6 to 12 months, not uncommonly, to get the model out of the lab and into that first production setting. So a modern production is an achievement, but how did that take as well is a question. Did it take an hour, or did it take a month? With MLOps and having that process defined, in addition to what Andrew said, we can really reduce that time to production dramatically if we have a defined process, and especially if all the groups in your org are doing the same process, then we can have everyone moving in concert, which means your time to value shoots down, as well as your time doing engineering and customizing, front ends and stuff. That kind of goes away, or at least gets, the effort gets reduced with a good MLOps framework in place. So now I can deploy models in hours rather than that 4 to 6 months it took me the first time I ever did it without MLOps really being a thing.
Okay. We have our first question in the chat, so I'm going to pivot to that. There's just a couple more, but I'd rather get this asked. So Mark asked, how does a model deal with corrupted data, whether intentional or not?
Well, assuming that corrupted data in this case, that could manifest in a couple of different areas. A lot of the times we're trying to work with the data in sort of a tabular, a table format, a matrix, if you will. And that's the way that the model usually likes to play. So any problems that you have with your data engineering in getting the data into that format is going to be something that you're going to have to consider. And that almost ends up being more of a data engineering exercise rather than a model exercise in itself. So making sure that you're able to handle exceptions and have requirements in terms of how you are training things and how you are evaluating things. If corrupted data in this case means that you're getting something that is outside of the purview of the model, say that our example model is either detecting if a picture has a cat or a dog, and you add in a picture of a donkey. Is that corrupted data? Is that non-appropriate data? The model is going to just attempt to make the best prediction that it can given the information that it has, and it will say, it's this donkey is kind of a low probability that it's a cat or a dog, perhaps. Maybe it would say that's closer to a dog. I don't know. And part of that leads into the overall cycle of data science and building a machine learning solution. As you're experimenting with things, given the data that you have, locally, you are always trying to see, how can I do this better? What other approaches can I have? What are the edge cases? How can I handle that? How can I handle them? Being able, when things are in production, and this is why MLOps is important, and keeping an eye on data drift is very important, is making sure that your solution over time matches the problems that people are trying to solve with that model. Machine learning models, while under the hood there's a lot of complex math, they're still computers, and they're going to do exactly what you tell them to do. If you train it like, is this a cat or a dog? It's only going to see the world as cats and dogs. So making sure to take these sort of things into account and reevaluating when you need to.
There are also other ways of corrupting data too. You often hear, well, you are hearing more, especially on the security side, about adversarial attacks on machine learning systems. Now, these tend to only impact either things that are publicly available. So, let's say I've got an app publicly available that can, again, do the cats and dogs example. What you can do with things like that is you can exploit the underlying mathematical structure of the problem. So there's a way of injecting what's called Jacobian noise into images, for example. So it's a very specific kind of structured but semi-random noise that can be used to direct the image as we see it. I think the pandas is an example of this. There's a thing about pandas. You can inject Jacobian noise into those images to make them appear to be something that's not a panda. Right. So to our human vision, that's still a panda, but the underlying math of the image has been changed in just the right way to manipulate the model in what's called an adversarial attack. So that's kind of a way of corrupting data in interesting and unusual ways. And what that can do, if you aren't careful, is what's called data poisoning. Because back to Andrew's thing about, we're monitoring our model. As part of that, we'll look at errors it made, and we'll often use those errors to retrain our model to make it better. That donkey, if a donkey comes through in our cats dogs thing, we might then want to, in our V2 model, add a donkey class as our third class, because we've seen, a lot of people are bringing us donkeys and it's making errors on donkeys because it doesn't know donkeys yet. But what someone could do is inject an image that looks like a cat that has been manipulated to be a donkey image. We say, it got that image wrong. So we'll bring it back into our data set to train on V2 of the model. And now that image has been poisoned. So that's an interesting kind of additional thing that's a bit more subtle than more explicit things, but also is a problem today in certain kinds of machine learning system. But those are rarely issues internally. Those are really more issues for externally facing systems rather than internally facing ones that say only have access to your resources behind your Azure environment, behind your virtual network scenarios.
Good question.
Thank you. Yeah, Mark, if you have any follow-up questions, please feel free to add them into the chat. We had another one come in that says, if a company has not ventured into machine learning at all, how would you suggest they get started in a way where the return on investment will be palatable for the company?
I can go first on this one, I guess. So one of the common errors that new orgs make in data science, let's say you've hired your first data scientist and You've hired someone who sounds great on paper. Some data scientists are very good, but many struggle with the idea that we have our metrics and our own way of determining if a model is good or not, right? Using stats measures of varying different kinds. Of course, the business doesn't care about that. They care about the question ROI. That could be a dollar amount. It could be a time saving. It could be new clients. It could be serving more people if they're a state government entity, for example. That's what matters. Some business metric. So step one of ML is always to define what the metric is going to be that we want to try and do better on, whatever that is for your organization. The next part to do is then to say, okay, so where could we make an impact? Where do we think we could do better, right? It could be sales, it could be marketing, it could be which teams do we think we could impact or move the needle on with an ML use case enough to matter to the ROI that we'll get. Right? Again, we don't want to do science projects. We want to do a real business thing that's going to have real value and really move the needle for a business. Then the last piece I would say is, look for something that is not too far away from what you're already doing. So you might already be using Power BI or Tableau or other BI system to do some really good visualizations on deterministic data. Hey, show me my operational metrics for my sales team for the last week, last 2 weeks, last month, last year. Fabulous. So you're already looking at your sales data. You already understand that data very well. So you've got people internally who know and feel and can utilize that data well. So we could say, okay, well, are there things which we say to optimize a sales pipeline, to help to prioritize sales leads that, ones that have a higher chance of closing, for example. That could be one way then of saying, okay, we've got a definite ROI, closing a lead. There's a definite link then to money there. Great, that ticks the box. The data is well known to us. We have people who are using it already, and there's a clear group who would benefit from us doing this. And that's just an example, but that's kind of how often we approach the thought process for deciding ourselves kind of where to start with a machine learning use case. There are great things that might be completely different to what you do today that are transformative, but they're also inherently more risky. And so I would kind of venture towards in your first steps something safer and nearer to your current business or nearer to your current data you're using, and then build up to the more transformational, riskier projects as you gain more internal buy-in to that, and see some early successes from early use cases.
Absolutely. I especially agree with the making sure that it's related to something that you already use, because a lot of the time people will try to find a problem that is really big, really complicated, and not at all what they're doing in their day-to-day. If they're not already doing it in their day-to-day, are they actually going to use it? This new thing that has inherent like randomness and a model is a representation of its understanding of data of the real world. It is not the real world itself. So really connecting it to something that the team understands allows you to get buy-in on the product itself, on the machine learning product itself. And then also you're able to see where there are improvements and caveats. And in business, a lot of the time when you introduce machine learning, it should be something, versus a deterministic approach or a rules-based approach. You should really be hoping that it is just doing better. Because if it is doing, say, 5% better than having, 6 interns doing an analysis or something like that, then, once you've automated the process, it's going to continue to give, returns in that way. The other thing that I wanted to mention was a lot of the time, people or recruiters or whatever will reach out to me on LinkedIn, and it will be like, lead data scientist position, for fast growing startup. You'll be responsible for, building an analytics warehouse, building natural language processing models, building forecasts, creating dashboards, et cetera, et cetera. And a lot of these companies, to me, when I see that, these people really don't know what they're getting into at all, because each one of those things is really somebody's full-time job. A model, if you want to build a good one, takes time. You need to iterate on it. You need to really understand the data almost as well, or even in some cases as better than the business users who are using that data. And then once it's actually in the wild, you often have to revisit it again and make appropriate improvements. So when you're starting on the machine learning, don't try to do everything all at once. Figure out what the problems that you really understand so that you can understand then the machine learning from an institutional standpoint better. And then you can expand out from there. Start with something you know, build on it, and then continue to expand out.
And I will just say that, at Tallan, we have a structured framework. When we start working with new groups, we haven't worked with before, we have a structured framework for trying to identify problems that kind of fit into that sweet spot of being tractable from the business side, but also having that kind of that impact on there. So we kind of have a structured framework that we follow to, identify with, quite high success rates, those kinds of problems that, would be in that sweet spot.
Awesome. We have another one. So what is a realistic timeline for a project to go from conception to full production for an MLOps engagement?
So, I mean, that's very variable is kind of one answer to that question. And it really depends on how experienced you are at doing all these pieces, right? So for us, brand new group, new data, we go in, blind, we can generally have an MVP done in a, 2 to 3 month time frame from literally, coming in and knowing nothing to having a full deployed thing out. Now, it doesn't mean it'd be perfect, right? It might need more, Andrew's point earlier on, more iteration, some rounds of improvement following that. But I'd say, reasonably, if you know what you're doing and you've got a good team in place, 2 to 3 months end to end. For most things, right? If you avoid, and Andrew's point earlier on, that those really complex, big, things that require like an actual research for it to be done, that's a rough.
Yeah. Just to give an example for something like that is like if you were trying to build like a custom vision model or something, might require a little bit more time, especially if you've never done anything like that before, versus like trying to solve a business problem, like who do you target to sell cars to or something like that. Sorry, I just kind of wanted to separate like what's a truly complex problem and what's something that's a little bit easier with accessible tools.
And one thing that we've done is, because building a model is always custom. Most of the time, there are some exceptions, but most of the time that's going to be a custom entity. Everyone's data is different, even the same vertical. You different systems, you collected it differently. Like it's very hard to take the exact code I did for say for selling cars, right? Dealership A and dealership B, the same data points might be different enough that the model for A doesn't work for B, right? Things don't always transfer trivially across. So it's always a bit custom there. But MLOps is not, right? We have an approach, you should have an approach for doing it that everyone follows. And so yeah, if you're building that from scratch, building that out might take 6 months from scratch if you've done it before. But if you've already got the frameworks in place to do it, then that's just almost a push button exercise. It's more of a quick integration exercise that takes a few days, rather than it being hey, we've got to build out a whole MLOps platform or framework from scratch. So that 2 to 3 months assumes that you have the pieces in place to successfully experiment, iterate, and deploy without having to build all the pieces themselves from scratch every time.
Yeah, and I'll also add that because we have the two parts. We've got the deployment and we've got the building of the machine learning model. And then we also have the third is the data engineering and making sure that you have the data in order to populate your model. I would say that building a first pass of a machine learning model is actually very, very easy. It really does not take very long. If you have the data, it's really not that much code to just slap the data on, figure out what you're trying to predict, et cetera, get some scores out, and then see how you are doing. But again, I know we've highlighted it a couple of times, but the amount of iteration that often goes into these models is usually pretty robust, because say you do your first model, you're going to have missed something. There's going to be some edge case that is going to be important for your decision that you will have missed. So then you're going to have to work with data engineering, get that additional data, and iterate. Maybe you've come up with an idea of additional features you want to engineer rather than as it is in the data warehouse. Being clever about that and avoiding data leakage, which we can go into later if we need to, is usually has some nuance. Figuring out which levers you want to pull, all these things continue to take time. And part of the art of data science is figuring out when do you start, or sorry, when do you stop cycling just in the model building and decide that you have a good enough proof of concept and can move into production, versus realizing that something isn't quite up to snuff. And that requires a lot of communication. But getting a first pass just machine learning model shouldn't take too much, like more than a couple of weeks, if the data is in a suitable place. And then, like Lee said about the MLOps, totally depends on what the infrastructure that you previously have is like.
Okay, awesome. So we just had another one. When would a business hire a data scientist compared to a data analyst?
So I'll start here with a bugbear that I have. In many businesses, the data analyst role is being rebranded as data scientist. This started maybe 3 or 4 years ago, and it's carried on in many places because it's a sexier title. And this frustrates me a lot, not because of elitism. It frustrates me because the analyst position and the science one are two different, or should be different roles, doing different things, both of which are extremely valuable to a business, right? But they're looking at different arms of the business. This is now opinion based, of course, and Andrew may have a different one. But my view is that data analysts, what they're really good at is knowing the data really well. They're often the closest to the business from kind of the suite of data roles that we might have. And they do the important work of making sure that data is good quality, it's understood well, that it's displayed well, the storytelling aspect, building, designing good quality dashboards, doing good quality analysis on historical and operational data. That's hugely important, right? If you don't know where you are today or where you were yesterday, you can't move forward. And honestly, the analyst role is often a precursor to data science, right? If you're doing the data analytics well, how that looks for your business, that's often when you're ready to do data science. Data science approaches a different kind of question. The analyst is looking at the deterministic, the what happened, what is happening, what does data tell us now? Data science often looks at the ambiguity question, right? Hey, what will happen in the future? What will, of these 3 decisions, which one has the highest probability of being the right one to make, right? Inherently things where we can't know the answer because there's inherent uncertainty, inherent ambiguity, and even the question we're asking in the first place. So if you have no data analysts in place and you're hiring a data scientist, honestly, they'll be fulfilling a data analyst role.
I definitely agree with that. The path to having a mature data organization definitely starts with the data engineering and the data analysts. You need to be able to access your data and get answers from your data before you even want to start considering trying to build predictive models based off of that data, because you could end up hiring a data scientist who ends up being, very expensive, and they're not going to have the tools that they need in order to be successful. And the things that they will want to provide, i.e. the machine learning models, are likely not going to be as valuable as the sort of analysis that is able to be provided by the a data analyst role. So like Lee said, if you hire a data scientist, you know, you're going to be having them doing something that is not, you'd be better served with a data analyst. Another way of putting this is if you aren't able to get a good understanding of your data via Power BI, then you probably aren't ready for a data science solution unless the scope of that data science solution is not really related to the business and it's much more procedural. You know, like we desperately need a way of categorizing emails, perhaps. Like that's important to the business, but that's not, you know, focusing on selling something. But it's kind of more a tool that helps you do some of your day-to-day work. Also, one thing that's interesting about this is, on the other hand, is that sometimes I've seen companies wait too long to hire a data scientist because they are getting so much value from their data analysts. And with data analysts comes more information, and information is power. So they get more information, they get another idea, they build another dashboard, then somebody from another part of the business, oh, I've got another idea for a dashboard, I've got another idea for a dashboard. And then the company gets so focused on those sort of answering questions, they run out of bandwidth to be able to start looking forward. One reason to get a data scientist involved when you are able to answer those questions is that the way that data scientists approach data and the way that they approach questions often increases the fluency of data within the entire organization, because there's a lot of you know, strict rules in how you collect and prepare data that can either become part of your data engineering workflows, or by organizing the information in a certain way or asking a question in a certain way can give you additional insights from your data that you may not have found just slicing and dicing by yourself as a data analyst. So certainly start with the data analysts, start with the data engineers, but don't wait too long to get that data scientist involved.
Thank you. Next one is, how does the data science or MLOps team ensure the security and integrity of the environment being used during the different phases of development and production?
Don't trust the data science with security.
True.
I will start with that statement. By the very nature of data scientists, and I often use the analogy of, data scientists are like pirates. Okay, fabulous at using data to solve all kinds of really cool problems in interesting ways, but their power is innovation. It's in development, ideation, exploration. It's not in security. So if you give a data scientist an inch, they'll take a mile, right? If you open up all your data sources to a data scientist, that because often for our models we need access to many data sources. We might need data on customers, sellers, marketing, operations, events, to build a model that kind of encompasses all the things that we need, all the bits of information that we need to forecast something, to predict something, to categorize something. So if you let them do that, they will do that with no regard for security whatsoever. Organizations are like navies, right? You want everyone to be moving in the same direction, with best practices, because what you don't want to do is have a data scientist download a database table down to their own machine and leave it on a train, right? And have it, and then that's where your data can be stolen very easily. Or, like I've seen happen in the past, a long time ago, data scientists is annoyed that what they have around doesn't run fast enough, so they send the data to their own server to process a machine learning model faster. You just had a massive data exfiltration. So it's actually most incumbent on creating a safe environment for data science to work in, which honestly, it's good to have a data science architect, someone with a broader view involved in that conversation, because again, you don't want to make it so locked down they can't do their job. So the key piece with security and integrity is to figure out, by involving central IT, and analytics people and security people and data science people, what's the right pattern? What's the right balance of, guardrails and openness that enables data science to do their job, be productive, be innovative, whilst at the same time making sure they can't break things, they can't be insecure, they can't unthinkingly do something dangerous that could expose stuff to a hacker, that could exfiltrate data to a third party or outside your firewall. It is a hard question. We have an approach to that at Tallan. We call it our modern data science platform. But that's how over time and experience we've figured out kind of what we've noticed works at many orgs. But every org is different, right? In what that balance is going to be. So there's no hard and fast answer to that, but that's kind of an opinion on the question's philosophy, if you will.
Yeah, I agree with all of that. I don't have really much to add because again, I'm not a security expert. A lot of the mentality of data scientists is more is more. Being able to put, we always say, like when I'm teaching people different things, or if I'm leading a project and I've got like a newer data scientist and they'll just want to throw everything in. And it's like, no, let's think about the different features that we want to add to this model. How do we approach this in a good way? But there is, a temptation to just want to throw everything that you have at the model, because the whole point of machine learning model is that it can learn the patterns that you don't have. So again, making sure to have an environment where data scientists can work and have access to a lot of the information is important. And then also making sure that the culture of your data organization understands the needs of the data scientists, and the data scientists conversely understand the needs for security. There's always going to be friction in organizations. People can be frustrated, that sales, for instance, are selling too hard, but at the end of the day, you've got to sell things. Same thing with data scientists and security. There's going to be some friction there, but you have to figure out, everybody's on the same team. What is the appropriate amount of information? Does it support the problem? And are we just doing it because more is more, or because there's a deeper need for this sort of information?
And production is often an interesting kind of thing, right? Because you've got dev, which is, obviously might be have more openness in some regards, because it's, say, purely internally facing. There's no external facing part. Production might have APIs that reach out to third parties, that reach out or that are open to the public internet. If, say, you're a product provider or a service provider who has a website, or who has a partner who's involved and you call your API to get some information from you internally. And different orgs have different answers on who should access production, right? In many cases, data scientists themselves might prepare everything for production, but I've regularly seen data scientists themselves don't have access to production itself. That's going to be maybe on an ML engineer or a collaborative group, not a separate group, but a collaborative group who perhaps are more trained in security, application security, who are strong on the software engineering side. Who can do more to ensure the integrity of those environments in production. There's various patterns for that as well. And you might even have a production environment for your internal applications that maybe is, data science can push to, and one for your externals that has to go through more approvals and be more gated and have more change management around it to ensure that those, externally facing entities are secure as well. So complex question, but there are ways to at least think about it.
That's good, though. I think complex is good for a situation like this. So I guess we have nothing more in the chat, everybody. We have about 10 minutes left, so feel free to keep adding them in there. But there were two more from the pre-emailed list of questions, and I think both of you have sort of started to touch on an answer to this, but I don't know if you've gone fully into it. So what kind of problems are best suited for machine learning?
You just muted.
I like this question a lot because it is kind of the whole point of the job of a data scientist. Figuring out what the best approach is. And some of my favorite projects that I've been on have been, identify fraud in this way, and we build a model, and it's got all this complicated data engineering, and fraud is typically a good problem for data science due to the uncertainty within it. And then as we were continuing to iterate, and I would find things, or the business would tell us additional information, we eventually scrapped the machine learning part of the model and then instead came up with a rules-based system in order to solve that problem. And the great thing about that was that the team understood exactly how everything worked. It was much more efficient, and they were able to then, by getting subsets and getting additional information, they created a process in which they could more and more easily just add additional rules for identifying fraud. That's not going to be appropriate for all fraud problems, but it was for this one. So when figuring out what problem you want to solve, even as you're solving it, be ready to try a different solution, even if it isn't a data science one. A lot of people will double down on things at machine learning. You're just not getting the metrics. They'll double down on the approach when maybe it's just not appropriate. But the difference between a rules-based solution and a data science solution is usually one where there is inherent uncertainty in the problem, and that is okay. One of the things that we really bump up against is there's uncertainty on the problem. How many people are going to be at a particular place at a particular time, and there's no flexibility on the correctness. It's a machine learning model. It's not an oracle. So if you need things to be 100% precise always, it might not be a solution for machine learning. There's a reason that when you're flying a rocket to the moon, there's not very much machine learning going on. There's a lot of physics and very specific instructions because the need for that precision is so high. And a lot of business problems, you need to be okay with some of that uncertainty.
I'll take a different tack with the question, and that is all excellent answer. So kind of the flip side of that is what maybe classes of problems are amenable to machine learning, right? And again, always will have ambiguity in them inherently, right? So one class of problems involves anything to do with spoken or written language, right? Analyzing texts automatically, mathematically. Nowadays that's all done with machine learning, right? Even down to summarize the text form automatically, classify these different emails into different categories. SharePoint has tons of ML built into it inherently nowadays, doing things like that. Even search algorithms now often use machine learning to index PDFs, to index non-traditional formats of documentation. Another one is computer vision. Anything to do with images, videos, right? Automatically extracting insights from those things. The cats and dogs images example, right? Perfect thing to do machine learning. Identifying objects, say fruit in an image, or landmarks, or even people. Great machine learners. Almost all automated image extraction and image analysis is now done with machine learning. Not true 10 years ago, but is true today. It just outperforms everything else on the market. And most of it's pre-built now as well, and with NLP and computer vision. So unless you're going way out there to something really novel, you often can build models with a little bit of customization, but built on a foundation of what already exists out there. So outside of those two areas, we have forecasting a future value of revenue, people at a location, saying what will the number of this thing be in a week, a month, a year, because in that thing, again, there's inherent that hasn't happened yet, right? There's inherent uncertainty in the future that can't be removed away. But if you can get a better idea of the future than you have today, you can plan better. You can say, get your supply chain better optimized because you're going to have a surge in orders, or you predict a surge in orders in 2 weeks' time, because that's what the signs are telling you is happening. You may not know the number of orders exactly, but even knowing there's a surge and knowing that, say, that it's a surge of 10% rather than 20% will be helpful to right sizing your, say, manufacturing operations today. Another area is people's behavior. Who will do something? What should they do? What could I do today to maximize the odds of someone buying my product in 3 months' time? The idea of the prescriptive analytics. What service should I own? If I'm, say, a provider of government services, what's the right service to offer this person with this set of challenges to help them integrate back into, say, to work or housing or anything like that? So again, people's behavior is inherently uncertain, right? When I myself woke up this morning, I knew I had this session, but I had no idea of what questions would be asked on it. There was inherent uncertainty there, therefore my answers are uncertain in advance. But I might have been able to forecast some of the answers, which we already had, to give better answers than we might have otherwise given if we hadn't even tried to think ahead and plan ahead for that. So there's just some classes of problem, in addition to sort of Andrew's description, that are also amenable in general to data science techniques.
Very interesting. So on the flip side, what kinds of problems are not well suited for machine learning? And if you want to say things that are inherently certain, you can do that. Or if there's some more detail to share, feel free.
So there's a way that this could go. Obviously, yes, certainty. If you can solve it with SQL or with Power BI, do that, right? Machine learning models, even in a certain scenario, will always give a margin of error because they're inherently probabilistic, right? If I've got a problem that can be solved 100% accurately with SQL and I build a machine learning model for it, I might only get to 95% accuracy. That's worse. That's inherently worse than my SQL solution was, right? Again, ML is a tool in our toolbox. It's not the thing that we do necessarily, right? It's just a tool in that. And it's something we do SQL work all the time, but often with a different focus to the data engineers. We might be looking to, say, join two unusual tables that have no common keys probabilistically. In fact, Andrew put out a blog on that yesterday on the Tallan website. Another area that you've got to think very carefully about is high-risk problems. So there are many cases where a human needs to be accountable for a decision, okay, especially like life and death, right? Medical sciences, doctors all the time make life or death decisions. Now, is a machine learning model helpful there? It can be very helpful in medical science. It's used very widely to do all kinds of things in medical science. The question is what and what the risk of harm of that model is going to be. Models are going to make mistakes. It's just built into the system. In medicine, if a mistake is made, someone could well die. So the question there is, at what point is machine learning appropriate given the risk of failure versus not? Now, that's not a trivial question to answer, right? It's very context dependent. And if doctors make mistakes, say, 10% of the time, and the machine learning makes it 5% of the time, then the machine learning model could be better, or at least be a very useful thing to inform the doctor's decision-making process. But it probably shouldn't replace it because of that risk factor.
Okay. Andrew, do you have anything to add?
Yeah, I think that I was going to add something, but I think that Lee really actually hit it on the head. And a lot of the stuff that Lee kind of mentioned also goes into a broader discussion that we've had before in regards to responsible AI. So if you are doing something that can impact people, make sure to consider how the model is being trained. There have been problems like with automated loan approvals and that sort of thing, where it takes into account, location or race or other things, and releasing inherently biased models. So maybe it's a good problem for a machine learning solution, but you also have to consider, is that the right, are you using data that is appropriate to solving the problem?
I think this is going to be our last question. If any of you guys have any more, do feel free to add them into the chat. And like I said, we'll put together a blog post with an answer for you. But this last one that came in said, do clients usually come to Tallan with a specific problem or goal, or do they usually come to Tallan asking what this data they have can tell them? Off of that, how directed are most of the data science projects that you work on?
But it's both. Some come, they already have maybe a data scientist in house. They've already worked with somebody and things didn't quite go right. So they're looking to come in and kind of help us help them. Of course, they don't always come to us with the right problem, right? Sometimes we need to help them to iterate that and create that. Now, in the case of, hey, we want to do some AI, give us some AI. That happens more often than, well, maybe not more often than you think, but it happens fairly regularly. We have a structured approach for helping people figure out, I think we mentioned it earlier on, we have a structured approach for that scenario. We call it our vision map exercise that we go through. It's kind of like a 2 to 3 hour session that, we have a specific agenda, a specific way that we carry it out in order to try and elucidate what problems you have internal that would be good data science things, kind of using some of the criteria we just covered, and then mapping that as well, not only to, is it suitable, but also, what's the ROI going to be? What's the impact going to be? Oh, and how near is it to what you already do compared to, is it iterative in what you do? Again, they're often good starting problems, or is it, transformational, out there, crazy, maybe something for a later date? So we have that approach and structure that we go through to help and really get to the right set of problems. And then we obviously the project becomes directed because we have the top 2, 3, 4, 5 problems to work down. And hey, if problem 1 isn't amenable when we do our analysis and we do feasibility work, well, number 2 maybe. So then we come down to number 2 and say, okay, let's try number 2 now. Fail fast, right? No one wants to be sitting on a project that isn't going to work because that's not right for either my consultants or for the client team.
Absolutely. And part of the effort is when people do have a solution, maybe they're coming to us because they don't have a data science team and they'd like to leverage ours. They have an idea of a sort of solution or a problem that they want to solve. But the scope of it is too large, and that's fine because they're not the experts, but they know what is bothering them. But we've had situations where they're trying to predict, what of these 32 different types of problems can arise, and we have 100 examples. Well, maybe we filter that down a little bit. Is there are there maybe 2 or 3 main problems that would give you the most bang for your buck, because that's something that we might actually be able to solve. Whereas if we tried to tackle all 32, there's just not enough information. So the whole gambit, with the vision mapping exercise, we're able to kind of see, where are you, meet you where you are, and then build the problem out appropriately.
Okay, that's awesome. Thank you guys so much for your time, and thank you everybody for joining us today. Like I said, we are going to send this recording out to you sometime tomorrow, and you will have Lee's and Andrew's LinkedIn information in there. Definitely, please feel free to contact them, contact us to ask any further questions that you have, and hopefully their passion for data science came through in this event. I definitely think it did. So have a great rest of your day.
Thank you so much, everyone.
Thanks, everyone.